There is a sweetener that healers in ancient Egypt packed into wounds to stop infection, not as a last resort, but as a first response. It does not expire, ever. Archaeologists have opened 3,000-year-old Egyptian tombs and found jars of it still perfectly preserved, still chemically active. The pharmaceutical industry sells antibiotics at $200 per course for conditions this substance has treated since before written language. Its name is honey, Apis mellifera's gift, and the story of how medicine forgot it is not an accident. This is the story of a healing compound so effective that during World War I, Russian military surgeons packed it directly into surgical wounds when antibiotics did not yet exist, and reported infection rates dramatically lower than field hospitals using early antiseptics. A compound with 181 bioactive constituents, including hydrogen peroxide, methylglyoxal, and defensin-1, a protein secreted by B immune systems that no laboratory has successfully synthesized. A compound that a $900 billion global pharmaceutical industry spent decades reclassifying from medicine into condiment. In 1550 BCE, an Egyptian physician opens the Ebers Papyrus, the oldest surviving medical text on Earth, and finds honey listed as an ingredient in 900 of its 877 remedies. Not a few, not occasionally, systematically, for eye infections, skin ulcers, surgical wounds, internal fever. The ancient Egyptians were not guessing. They were documenting a compound they had studied across generations, watching it do something no other substance did consistently: kill pathogens and accelerate tissue repair simultaneously. Across the ancient world, the pattern repeated. Hippocrates prescribed honey mixed with vinegar for pain management in 400 BCE. Ayurvedic texts from 2000 BCE classify honey, madhu, as one of the 5 sacred elixirs. Chinese pharmacopoeias from the Han Dynasty list over 30 medicinal applications. These were not folk traditions built on hope. These were clinical observations refined across centuries of use in populations numbering in the millions. Then came the 20th century. Then came penicillin. The discovery of penicillin in 1928 was genuinely revolutionary. Nobody denies this. But what followed was not just the rise of antibiotics, it was the systematic professional discrediting of anything that could not be patented. Honey could not be patented. A colony of bees does not file intellectual property paperwork. So what happened to 3,500 years of documented clinical use? In 1955, the American Medical Association quietly removed honey from its list of approved wound treatments. No clinical trial showed it failed. No large-scale study demonstrated harm. The medical establishment simply pivoted towards synthetic compounds that pharmaceutical manufacturers could control, price, and distribute exclusively. By 1960, medical schools in the United States had stopped teaching honey's therapeutic applications entirely. A physician graduating in 1965 knew nothing about it clinically. The knowledge did not die in a fire. It was not banned. It was quietly excised from curricula, generation by generation, until the absence became invisible. The pattern repeats. Purslane was poisoned with herbicide. Amaranth was banned by conquistadors for enabling indigenous sovereignty. Fava beans were replaced by pills. Whatever enables healing without corporate involvement gets reclassified, from medicine into food, from treatment into superstition. Honey became something you stir into tea, not something a surgeon reaches for. Then came the scientists who did not care about patents. In 2007, a microbiologist named Sebastian Molen at the University of Waikato, New Zealand, published a landmark analysis reviewing over 400 published studies on honey's antibacterial activity. His conclusion was precise. Specific honey varieties demonstrated measurable effectiveness against 60 species of bacteria, including MRSA, methicillin-resistant Staphylococcus aureus, the infection that kills 19,000 Americans annually, and which modern antibiotics increasingly cannot touch. MRSA develops resistance to antibiotics because antibiotics typically attack one biological pathway. Bacteria mutate around single mechanisms. Honey does not work through one pathway. It works through a minimum of 4 simultaneous mechanisms: hydrogen peroxide disruption, low pH acidification, osmotic dehydration of bacterial cells, and the methylglyoxal compound unique to Manuka honey, which binds directly to bacterial DNA and prevents replication. Bacteria cannot mutate around 4 simultaneous attack vectors. This is not a claim. This is a published biological mechanism that any microbiologist can verify. In 2009, the Cardiff University School of Pharmacy conducted a clinical trial on chronic wound patients who had failed to respond to standard antibiotic treatment. 18 patients, wounds that had not closed in an average of 9 months. Honey dressings were applied. 14 of 18 showed measurable improvement within 4 weeks. The remaining 4 showed no deterioration. The cost per treatment? Approximately $2 per dressing. The average prior antibiotic course cost per patient? $340. In 2014, a double-blind randomized controlled trial published in the journal Pediatrics evaluated honey versus dextromethorphan, the active ingredient in most over-the-counter cough medicines, for childhood cough. 300 children. Honey scored statistically superior to the pharmaceutical compound on every measured metric: cough frequency, cough severity, and child sleep quality. Dextromethorphan generated $400 million in annual U.S. sales that year. Honey costs $8 per jar. The mechanism inside the body is worth understanding precisely. When honey contacts a wound or mucosal surface, it releases hydrogen peroxide slowly, at concentrations low enough not to damage tissue, high enough to kill pathogens. Simultaneously, its acidic pH of 3.2 to 4.5 creates an environment hostile to bacterial survival. Its high sugar concentration draws water out of bacterial cells through osmosis, collapsing them. And in Manuka honey specifically, methyl glyoxal concentrations between 100 and 800 milligrams per kilogram inhibit bacterial DNA-gerase, the enzyme bacteria require to replicate their genetic material. Remove that enzyme, bacteria cannot reproduce. The infection does not become resistant, it simply stops. This is not alternative medicine, this is chemistry. Manuka honey today carries a unique Manuka factor rating, UMF, that quantifies its methyl glyoxal concentration. A UMF 20+ rated jar costs between $50 and $80 at specialty health stores. Standard pharmaceutical antibiotic cream for wound treatment costs $60 to $120 per tube, requires a prescription in many formulations, and carries documented risks of contributing to antibiotic resistance. Manuka honey requires no prescription, carries zero risk of resistance. And the Waikato District Health Board in New Zealand has been using it as a standard wound treatment in public hospitals since 2004. In New Zealand, it is medicine. In the United States, it sits between the peanut butter and the jam. The same compound, different classification. The difference is not efficacy. The difference is patent eligibility. Nobody owns the Manuka tree. Nobody owns the bee. A healing compound that cannot be owned cannot be profitable at pharmaceutical margins. So the FDA classifies Manuka honey as a food ingredient, not as a drug. Despite 400 published studies demonstrating clinical activity that many synthetic drugs cannot match. Raw honey is identifiable today by its opacity. It clouds and crystallizes at room temperature, unlike processed honey that has been heated above 40 degrees Celsius, destroying its enzymatic activity and most of its bioactive compounds. The jars labeled pure honey in most supermarkets contain a heated, filtered product with hydrogen peroxide, largely destroyed, defensin-1 largely destroyed, methyl glyoxal largely destroyed. It tastes like honey. It heals like sugar water. Real raw honey smells of the hive, faintly waxy, faintly floral, with a weight and depth that processed versions cannot replicate. It granulates. It solidifies. That crystallization is not spoilage. It is proof of integrity. It is the physical evidence that nothing has been cooked out of it. The bees still make it. The Manuka trees still flower on hillsides in New Zealand. The bees in your own region still produce raw honey, carrying bioactive properties specific to the plants in your landscape. Clover, buckwheat, thyme, heather, each with documented antimicrobial profiles that reflect their botanical origins. It has not disappeared, it was reclassified. The healers of 3,500 years knew something a medical school curriculum stopped teaching. The Egyptian physician, the Ayurvedic Vaidya, the Roman legionary surgeon, they did not have clinical trials. They had something older, unbroken empirical observation across generations, with no financial incentive to forget what worked. The wound still heals. The bee still works. The knowledge is still here, waiting in the oldest medical text ever written, waiting in jars in specialty stores, waiting in the hive at the edge of someone's field. What was not lost was the medicine. What was lost was the willingness to remember it. If this vault opened something for you, subscribe to our channel and hit the bell. Every like and every share preserves what they tried to erase. The next vault opens soon.